Oh, hello guys and good evening. So this is the part 3 of our project on solving the water crisis issue in Majindogo. So without wasting much time, I'll just move straight into it. Okay, right. So this is a message we received from our auditor. I'll just skip this. And then there is also a response from the president. I'll also skip this. Okay. Now I'm back to Chidi on the ERD. So okay. So hey, it's been a while. I hope you are ready to get stuck in. We got back the auditor's report, so we need to compare their results to ours. To integrate the auditor's report, we will need to access many of the tables in the database. So it is important to understand the database structure. To do this, we will really need to understand the relationships first, so we know where to pull information from. Can you please get the ERD for the MD Water Services database? Spend a few minutes looking at the diagram. Okay. So I have already done that, but let me try and do it again. Right. So I'll import in a new script for the MD Water Services, right? So MD Water Services, I'll rename that as 3 so that it doesn't conflict with what I am already working on. So this, I'll just do it this way and then I'll execute. Okay. Okay. So it worked. Let me refresh my schema. And there we have it, MD Water Services 3. So that is what we'll be working with, right? And let me close these diagrams that I did earlier on. Okay. So we need to get the ERD for MD Water Services data. So in order to do that, we'll click on the database and then reverse engineer. Okay. We'll ensure that our connection is the same as the connection we are working in. So local connection 1. We go to next. We ensure that all of these are checked. We move to the next one again. We are using MD Water Services 3. So I'll only check that one and move to next. Retrieved objects and results have been checked. So next, and then we have a total of 8 objects and 8 selected here. So when we show the filter, you can see the tables we have in our database, okay? And we should always ensure that the place imported objects on a diagram is checked. So let's execute. Okay, so successful. Click on next and then finish. So here we have the ERD for the tables we will work with. Let's rearrange it to see the links between the various tables, right? So let me bring this one up here, so we know which those that have relationship with the others. Okay. So let me bring this in the middle here. Let me bring all pollution here. Trying for us to see where each one aligns so that we don't have a conflicting situation here. Okay, so we can now see that most of the tables are connected to the visits table. Right, let's go back to our slide. So note that the visits table is in the central table, is the central table. Location ID, source ID, and assigned employee ID are primary keys in their respective tables, but are all foreign keys in the visits. So when we click on the visits table, location ID, source ID, and assigned employee ID, those highlighted in green are all, what's the name? Foreign keys in the visits table. But when we go to their various tables, source ID is a primary key. I mean, in a water source table, location ID is a primary key in the location table, and it goes on like that. These are mostly one-to-many relationship. Let's think some of these through so we are sure this is correct. The visit table logs all the times we've been to different places, and we can see that some locations have been visited multiple times. On the other hand, the location table has all the specifics about each place we've been, but it only includes each location once. So it is a one-to-many relationship. For each unique location in the location table, there might be many corresponding records in the visits table detailing all the different times we went there. So let's look at the relationship between the visits and water quality tables. For every entry in the visits table, there should be one unique corresponding record in the water quality table. This means each visit recorded is associated with a specific water quality source, ensuring a one-to-one relationship between the visits and water quality table. Okay. But if we look at the ERD, it shows a many-to-one relationship. This does not agree with our thinking, and errors like this can cause problems. So let's fix that. So what we are going to fix is the visits and the water quality table, right? When we look at the visits table here and the water quality table here, it is a one-to-many relationship, but according to the statement we just read, it is not supposed to be so, right? Because there can be unique visits under the what's the name? The water quality, right? So we should normally be careful making a change like this. First, you should check that the record ID is unique for both tables and are indeed one-to-one. Okay. So I did that. So all we have to do is right-click on the relationship line and select Edit Relationship. Then at the bottom, select Foreign Key tab and change the cardinality to one-to-one. Now the relationship line should indicate a one-to-one relation. So we will click on the Edit Relationship on this line. So on this line, we'll right-click, we'll select Edit Relationship, and at this menu, we will select the tab Foreign Key. Under cardinality, we will change it to one-to-one, and there should be a change in the relationship here. So now we have a one-to-one relationship for the water quality and the visits table. Okay. So moving on, we are going to integrate the auditor's report. Now let's come back to our schema. Under the tables, these are the tables we have under the water services, MD Water Services 3 database. Okay. So we are to integrate the auditor's report into that database. Okay, I sent you a CSV file of the auditor's result. You should get it loaded into SQL. we would have to think back to the start of our journey on how to do that. So to make sure we have the same names, use this query to create the table first, then import the CSV file. Since this is the same table we are going to use, what I'll do is I'll just copy everything in here. So I'll copy this. Then I'll paste it here. Okay. So, okay. Once we run this, we should have the auditor report table created. Now let me refresh the schema. And we have it here under IMD Water Services 3. Okay. So let me delete this. Now the next thing to do is looking at the table in the data dictionary I sent you, you can see the type of info we have about. We have, yes. So when we open this data dictionary, we should see the info, but let's just move on. So first off, it looks like we have 1,620 records. So let me import the auditor's table report first. So under the auditor report table, I'll right click on the auditor report, and then I'll select table data import wizard. Okay. I will go and locate where my auditor report file is, and then I'll open. Now, before you do this, realize that when you download the report from our database here, it downloads as a zip file. So we'll need to extract the information from the zip file before we'll be able to select. If we don't do it that way, it's not going to work, right? So once we select our auditor report CSV file, we open, we click on next, next again, next again. So we're waiting for the data to import. Next, then we finish. So we have 1,620 entries in here. So if I should open this auditor report table, this is what we have: 1,620 rows. Okay, which corresponds to this. So let's move on. Which one was I working in? Yeah, I'll close this. Okay. Moving on. I see a location ID, type of water source, and that location and the quality source of the quality score of the water source. That is now independently measured. Our auditor also investigated each site a bit by speaking to a few locals. Their statements are also captured in his results. Sorry. We need to tackle a couple of questions here. Is there a difference in the scores? If so, are there patterns? For the first question, we'll have to compare the quality scores in the water quality table to the auditor score. So the auditor report table used location ID, but the quality scores table only has record ID we can use. The visits table links location ID and record ID, so we can link the auditor report table and water quality table using visits table. So first, grab the location ID and true water source score columns from the auditor report. So this is what let me query out the auditor report again. So find location ID, type of water source, true water source score, and statement. So we are supposed to come out with the location ID and true water source score from the auditor report table. Okay. So we will select location ID. and true water source score from the auditor report table. Okay. Now the next thing is I think it was sorted alphabetically. Okay. So now we join the visits table to the auditor report table. Make sure the subjective quality score, record ID. Make sure to grab subjective water quality score, record ID, and location ID. Okay. So we have location ID and true water source score here. We'll have to add visits location and record ID to this table. Okay. Before that, let's bring the visits table to see the items in there. So select everything from the visits table. Now under the visits table, we have record ID, location ID, source ID, and the rest, right? So we will add location and record ID to this table. So location ID and record ID to the table. Okay. Now what we are going to do is we will join the tables. Okay. So let's join. Let me arrange the script very well so that it makes sense. So we are going to join this is visits, our alias set, so that it becomes very easy for us to use. And then auditor report to our aliases at 8AR. So we found the location ID from the auditor report, and then true water score also from the auditor report, right? Now the next thing we are going to add is the visits location, which we can find on the location ID on the visits table. So visits, we aliased it as V. So we use V, and then we select the location ID. Then the next thing is record, which is also under the visits, and then record ID. Let me change the location ID to visits location here as visit location, and then we'll leave record ID as record ID. Okay. So now let's we are joining them on, so between the visits table and then the audit report table, there's one thing that can be used to link these two tables together. Over here, we have what's the name? Record ID. No, sorry. We can join the two. So the visit table links location ID and record ID. So we can link the auditor report table to water quality using, no, we've not gotten there yet. So let me do it over here. Right. So what I'll do now is, let me query the auditor table out. Okay. Now we can also see location ID here. So it means that the location ID can be used to link the two together, right? So I'll link auditor reports location ID to visits location ID. So once that is done, we should be able to join these two tables together, right? So this is how it looks like, okay? So going on, note that I specified from which table each selected column is from in this query. So yeah, this is the same query that we used here, right? But we aliased it. That is why our auditor report in here is just AR in here. Okay. Now that we have the record ID for each location, our next step is to retrieve the corresponding scores from the water quality table. We are particularly interested in the subjective quality score. To do this, we'll join the visits table and the water quality table using the record ID as the connecting key, right? So we are now going to add subjective quality score to all these existing table, and we can find that from the water quality table. Okay, so first off, let me bring out our water quality table. Sorry, yeah, water quality. So we have subjective quality score. Okay, now what we are going to do is we are going to join so this is water quality. Let me alias that as WQ. Then we'll join it on. But before we join, let me just, so WQ, we are looking for subjective quality score here. And then what can link the water quality, to the visitor or record table is the record ID. Okay, now we can find record ID in the auditor report table. Let me just double check and be sure. So auditor report. No, then it's no auditor report, it's visits actually. So from the visits table, you can also find record ID, right? So we are going to join this on. So visits record ID has a link with record ID in the water quality as well. Okay, so once we query it, once we run it, you can now see that the subjective quality score has been added to our table here. Okay, right. Now we see the scores from the auditors, and then this is from the workers. It doesn't matter if your columns are in a different format because we are about to clean this up a bit. Since it is a duplicate, we can drop one of the location ID columns. Let's leave record ID and rename the scores to surveyor score and auditor score to make it clear which scores we are looking at in the results set. So to do this, let me copy everything here and then just give a comment to know what we are coming to do next. So cleaning up, so that means we'll remove, okay, let me just do it this way. Clean up, then let me put this in bracket. So we will drop location ID. So drop in location ID. I'm going to use the same script we have here, but let's remove the location ID from the visits. Okay. And then and then we'll rename the scores to surveyor score and auditor score. So here we have auditor score and employee score. So, and which one also are we dropping? Okay, we will leave record ID. Let me bring record ID to the first so that it corresponds with what we see in our data. In our what's the name? Slide deck. So we will rename auditor score and employee score. So true auditor score will be auditor so score. Then this will also be okay. So once we we still have visits too. Once we query it, this is how our new table looks like. Okay. So since we are joining 1,620 rows of data, we want to keep track of the number of rows we get each time we run a query. We can either set the maximum number of rows we want from limit to 1,000 rows to a larger number like 10,000, or we can force SQL to give us all the results using limit 10,000. So looking at mine, I've already limited it to 50,000 rows. So I'm not going to tamper with that. Okay, let's analyze. A good starting point is to check if the auditors and employees scores agree. There are many ways to do it. We can have a where clause and check if surveyor score is equal to auditor score, or we can subtract the two scores and check if the result is 0. Okay, so this is how we'll do it. Under the same one, okay, I'll just copy and then paste it and give comments so that we'll know why we are doing that. I think that would also help. So checking if the auditors and employee scores agree. So that is how I'll name I'll comment on that. So checking if auditors and employees scores agree. Okay. So again, I'll copy this query. Take your time. Good. So I'll copy this query, then I'll paste it here. Now what we are going to do is we'll add a where clause and we'll say that where surveyor score or auditor score is equal to surveyor is employee, so where employee score is equal to auditor score. Okay, so where we can use auditor score and employee score like this, but that will not work. Okay, let's try that and see. So auditor score is equal to employee score. Okay, when we run this, it will not work because these ones are unknown columns in the table. Okay, so we'll actually use the name instead of the alias. Okay, so auditor score is the AR true water source score. So let's replace that. And then employee score is WQ subjective water quality score. So we'll copy that and then we'll replace this with this. And then let's run our query. So now we can see where the auditor score is exactly the same as the employee score, giving us 2,505 rows. Alternatively, we can also use or we can subtract the two scores and check if the result is 0. So it is going to be water source score minus subjective quality score equals 0. If this is true, it should return the same table, right? So let's see, right? We have the same table, but I like to go with the true water source score is equal to subjective quality score. That makes it a bit easier to understand. So you try and figure this one out. If you run into an error, remember that you can't use aliases in where. So you have to use the same name as in the select part, like this auditor report or true water source score, as we just did. Okay. So you got 2,505 rows, right? Some of the locations were visited multiple times. So these records are duplicated here. To fix this, we set visit count equals 1 in the where clause and make sure you reference the alias you use for the visit in the join. Okay. So we are going to further filter it to remove the duplicates. So we are adding visits. Now we see that and which one? So visits count. So visit count equals 1. Okay. Now in this case, we are trying to remove the duplicate locations from the table. After running this query, we found out that the number of rows have reduced to 1,518. Okay. What does this mean considering the auditor visited 1,620 sites? I think this that is an excellent result. So 94% of the records the auditor checked were correct. But that means that 102 records are incorrect. So let's look at those. You can do it by adding 1 character to the last query. So let me put a comment and then let's see how we'll be able to do that. So remaining 102 incorrect records. So let me do 102 incorrect records. I could have done everything in here, but I just want us to see the flow of how everything goes. So I'll only come here, copy this, I'll paste it, and then I'll do the change. So in this case, water quality source was equal to subjective quality score. That is why we got this, okay? But now I want to find the difference, the ones which are not equal to. Those are the ones that has a mistake. So to find that, we'll only say that where true water source score is not equal to subjective quality score, okay? And then once we run this, we'll have to get the difference of the actual table. So we are supposed to get 102 records, okay? And that is what we have here. So these are the tables with the errors or the discrepancies, okay? Sorry. So, but that means that 102, okay, this is what we just did. Let's move on. And then there's a table we got. Since we used some of this data in our previous analysis, we need to make sure those results are still valid. Now we know some of them are incorrect. We didn't use the scores that much, but we relied a lot on the type of water source. So let's check if there are any errors there. So to do this, we need to grab the type of water source column from the water source table and call it survey score using the source ID to join. Also select the type of water source from the auditor report table and call it auditor score. Okay, so we are now coming to add our auditor source and then the survey source to the table, right? So what we do is let's first identify. Let us first identify where we can. Okay, first let me bring out the auditor report table. Now we have type of water source here, so we can reference where was this one. So the type of water source comes after the location ID. So I'll look for location ID, and then I'll add type of water source. Okay. And then the next one is survey score, which is also under, where can we find the other type of water source score? So the first one is, yeah, so we can find the other one also from visits. Let me just double check and be sure. So visits, we have also, okay, so it's not visits. So let's look at maybe water source, sorry. So water source, yes, we have the type of water source here. So what it means is that we also have to add another join. You're coming to join water source. We reference that as WS. And then I'll bring that one also here, type of water source. Then now on which can we link the two together? So under water source, we have source ID, number of people served, type of water source. And then under the auditor report also, okay, we don't have source ID there. Let me look at visits. Visits also have source ID. So we can link it with the source ID on visits and water source, right? So once we do this, you can now see the type of water sources in here. Now we're told to name them as auditor score and survey score, right? So, sorry, auditor source and survey source. So this will be auditor source, and then this will be survey source. Okay, so we have auditor source and survey source in here. Kindly pardon me, let me just, does it even mind? I wanted to bring a comment and then work on that, but it doesn't really matter. Let's just go on. So what I can see is that the types of sources look the same. So even though the scores are wrong, the integrity of the type of water source data we analyzed last time is not affected. Once you are done, remove the columns and join statements for water source again. Okay. So once you are done, remove the columns and join statements for water sources again. So let me just drop the sources here because I don't think we'll need it again as we've been told to drop it. Okay, so let me just delete this too, and then we'll have this table back. Okay. We can even remove this join because we are not using the water source again. That should also work. Good. Now we are coming to link the records to employees. Next up, let's look at where these records may have come from. At some of the locations, employees assigned scores incorrectly, and those records ended up in this result set. I think there are two reasons this can happen. These workers are all humans and make mistakes, so this is expected. Unfortunately, the alternative is that someone assigns scores incorrectly on purpose. In either case, the employees are the source of the errors. So let's join the assigned employee ID for all the people on our list from the visits table to our query. Remember, our query shows the 102 incorrect records. So when we join the employee data, we can see which employees made these incorrect errors. So let me add a comment, linking records to employees. Okay, so as usual, let me just copy this same script here, paste it. So we are going to add the employees table to it. So in this over here, let's join the assigned employee ID for all the people. Okay, so we are coming to add employee ID. Now, where can we find this employee ID? So let me select everything from the employees table, and then let's see. So we have assigned employee ID in the employee table. And also let me see the, is it auditor report? No, auditor report doesn't have assigned employee ID. Let me see visits. Visits also have assigned employee ID. So we can link the two based on visits and employee table, right? So now we are going to add assigned employee ID here after the record ID. So let me bring this back. And then after record ID, let me bring the join function first. So let me give employee an alias as E. Okay, so I'll put E, then assign employee ID here. So I'll join employee on, so we have from visits, we have assigned employee ID, which is equal to, what was the other one? Employee. We also have an assigned employee ID. Okay, so once we run this, we should have the employee ID added to our table here. Okay, as we can see. So now we can link the incorrect records to the employees who recorded them. The IDs don't help us to identify them. We have employees' names stored along with their IDs. So let's fetch their names from the employee tables instead of the IDs. Okay, so once we replace the assigned employee ID with the employee name here. So we can still bring out the employees table. We can bring out the employee table. And a moment, please. Okay, so we have the employee name here under the employee table. So which other table? Okay, so we can link also the assign employee ID over here with the, okay, so I think with this, the only thing we'll change over here at the top is the, right, is the assign employee ID. So let me just give a comment. So replacing employee ID with employee name, replacing assigned employee ID with employee name. So let me copy all of these. Okay, take it easy. Okay. Let me copy all of this here. Then add it, paste it here. So with this, we are only going to change this column, assign employee ID to employee name, and then we are done. Okay. So now we've replaced the assign employee ID to the employee name. And since the join will still be on that same tables that we linked together, we're not supposed to change anything, right? So as we can see, they've been replaced by the names in here, right? Well, this query is massive and complex, so maybe it's a good idea to save this as a CTE. So when we do more analysis, we can just call that CTE like it was a table. Call it something like incorrect records. Once you're done, check if they select everything from incorrect records. Here's the same table back. So what we are going to do now is to create CTE. Incorrect records. Let me put that in bracket. Or incorrect records. So once again, let me copy everything here. I keep copying because it contains all the scripts we will need to run the query. Okay. So creating a CTE, we'll start with a with function. Okay. So with, and the name that we want to create, we want to call it is incorrect records. Okay, so creating incorrect records as, let me paste, close this bracket. No, sorry. Let me work on the one here. I'll indent it a bit. So okay, so as we have it here, we are going to use this the same function we used at the top, equal to 1. Okay, let me do it this way. I think the space is a bit wide, so right. And then let's select everything from incorrect What's the name? Incorrect records, right? So I'm going to select everything from our incorrect records. Let's see if it gives us the same table. Great, it did. So we've created our CTE. Okay. So moving on. Now that we've defined incorrect records, we can query it like any other table. Let's first get a unique list of employees from this table. Think back to the start of your SQL journey to answer this question. So, unique list of employees. Let me put a comment there. Unique list of employees. So, using the same CTE, so I'll copy everything here. And then I will paste it down here. And then instead of select everything, I'll select distinct. Then we want employee names. Okay. So employee. And once we query this, to be employee name, I only did employee, sorry. So once we query employee name, we should have 17 results as we can see here. Okay. Next, let's try to calculate how many mistakes each employee made. So basically, we want to count how many times their name is in incorrect records list and then group them by name, right? Okay. So it's just like calculating in any other table. Okay. So this is our this is our table we are working with. So we are now, after the employee name, the next thing is to identify the number of mistakes or errors that are associated with their name. And we've been told to use the count function. So we will count employee name. Then let's call that as number of mistakes. Mistakes. Okay. Incorrect records. And since we are using an aggregate function, we will need to group it. Okay. So group by, let's also group by employee name. Employee name. Okay. So once we run it, this is how it looks like. Okay. So we can also maybe order it by a number of mistakes. So order by, we can type the number of mistakes there like that. Then it will work. We need it from the highest to the lowest, so in the descending order. Okay. So that is how it looks like. Okay. Looks like some of our surveyors are making a lot of mistakes, while many of the other surveyors are only making a few. I don't like where this is going. So moving on to almost getting to the end of it, we have to gather some evidence. So gathering some evidence. Okay. So thinking about this a bit, how do we go about finding out if any of our employees are corrupt? Let's say all employees make mistakes, but if someone is corrupt, they'll be making a lot of mistakes in quotes, more than average, for example. But someone could just be clumsy. So we should try and get more evidence. Our auditor did say some of the things he heard on the streets were quite shady, and he recorded this in the statements column. Considering both of these sources, should give us a pretty reliable answer. So let's try to find all the employees who have an above average number of mistakes. Let's break it down into steps first. We have to first calculate the number of times someone's name comes up. We did that in the previous query. So let's call it error count. Okay. So let's move on. Then we need to calculate the average number of mistakes employee made. We can do that by taking the average of the previous query's results, something like this. Okay. And let's call that result average error count per employee, which would be a scalar value. Finally, we have to compare each employee's error count with average error counts per employee. We will call this result set our suspect list. Remember that we can't use the aggregate result in Y, so we have to use average error count per employee as a subquery. Okay. So in order to do this, let's start by cleaning up our code a bit. First, incorrect records is a result we will be using for the rest of the analysis, but it makes the query a bit less readable. So let's convert it to a view. We can then use it as if it was a table. It will make our code much simpler to read, but it comes at a cost. We can add comments to CTEs in our code. So if we run to that query a year later, we can read those comments and quickly understand what incorrect records represent. If we save it as a view, it is not as obvious, so we should add comments in places where we use incorrect records. Okay, so what we are going to do now is to save the CTE as a view. Okay, so saving CTE. Okay, so incorrect records as view. So where is our table for the incorrect records? Let me go and copy. Okay, this is it. So let me just copy everything in here. And this is what we are going to use to create our view table, right? Okay. So instead of starting or beginning with width, in creating a view, we only change the width to create view, and then we leave the rest as it is. Okay. So once we execute this, we should have a table down here where we can see these views. So let me refresh the schema, and then under views, we have incorrect records, as we can see here. Good. So we are making progress. Now, yeah, this is what we just ran. So we can select everything from incorrect to see if we can get the same thing. So as the incorrect records we saw above there. So let's just do that and see incorrect records. And there we have it. So our view worked. Next, we convert the query error count we made earlier. We didn't do it, so let's just do that one. So we'll change all of this to error count. Let me copy all of this. Okay. So the error count, we didn't create it, but let's just try and create it down here first. So creating error count CTE. So we'll begin with error count. You know, in calculating for the error count, this is what we're supposed to use as the where was that one? We found it somewhere here. Good. This one. This is what we use to calculate the error count. Select distinct from employee table count, and then from the incorrect, select distinct employee name, and then we count the number of mistakes from the incorrect. So this is what we use to calculate the error count. Okay. Oh, didn't add the group by employee name. Sorry. So let me paste this here. Then select everything from error count. Okay. So this is the CTE for our error count. Okay, we're supposed to create this earlier, but I don't know what happened. It escaped me. Okay. Let me just, I wouldn't want to add the order by, so I'll just tap on this to order them. So we are done with, next we convert our error count into CTE. That is what we just did. Okay. Now calculate the average number of mistakes in the error count. You should get a single value. Okay. So in my back. Sorry. So let me just put a comment here. Calculate the average number of mistakes in error count. So calculate the what's the name? Average number. Average number of mistakes. Sorry. Wow. Mistakes in error count. Please don't call. Please don't call. Okay, so I'll copy everything here because that is the same thing we are going to use to calculate. But in this case, so we will first select employee name. And then the next one is we are calculating the average number of mistakes in the error count. So average number of mistakes. Easy. So let me see if this will work. This might give an issue. So average mistakes. Yes, we got an error. We got an error. So in aggregate query without group by expression contains an aggregate column error count. Okay. So let me see. Okay. Let me rather do it this way. Sorry. So instead of the count here, let me only change this to average. Yeah, simple. So calculating average. Okay, so I think instead of doing it here, I wasn't supposed to do it. So now let me run this query. Hey, you're not supposed to group by you. I'm supposed to get a single digit, so please don't play rough with me. What is this? Okay, Let me just remove the employee name because I just need a single data. I'm not doing it for other employees here. So let me run this. 0. And what is happening? So select average employee name as number of mistakes from incorrect records. And then I'm selecting everything from error count. Why am I getting 0? Okay. Let me do this and see. So average employee name. Still getting 0. No, it's not supposed to be 0. Average number of mistakes. It's not supposed to be 0. It's not supposed to be 0. Let me reference this and see. Why am I getting this? So this one, getting this. I should get a single value. Yes. So let me check from the one that I worked on. So this. Yeah, that's the same thing. This one gave me 6. So why am I getting something different? So select employee name, count employee name from incorrect. Group by employee name, and then we select average number of mistakes. Oh, number of mistakes rather. Okay, sorry. So number of mistakes. Okay, good. So yeah, we are good to go. So now we've been able to calculate the average number of mistakes. It was even here as simple. In the error count, you should get a single value. Yeah. So yeah, you get a shot. Now the third thing is to find the employees who made more mistakes than the average person. We need the employee's name, number of mistakes each one made, and filter the employees with the above average number of mistakes. So let me insert a comment first. So employees who made more mistakes. So let me do it that way. Employees who made more mistakes. So let me just copy this thing. We need the employee's name, the number of mistakes each one made, and filter the employee's name with the above average. Okay. So select employee's name, number of mistakes each one made. So employee name, number of mistakes each one made, and filter the employee. Okay. So where okay. Is the number of mistakes is greater than let me do it that way and see where of mistakes is greater than. So this is what we use to calculate the average. Where are you? Where are you? Where are you? This. So we are using a subquery. Then let me close this. Please work. Yes. So we calculated the employee name and then the number of mistakes from our error count. And then this is what we use to calculate the average number of mistakes for one. But we are saying that where average, we have to filter employees with an above average number of mistakes. Okay. So above, we can sort it alphabetically and then we get the same thing as we have here. So there they are, our culprits. These are the employees who made more mistakes on average than their peers. So let's have a closer look at them. We should look at the incorrect records table again and isolate all of the records these 4 employees gathered. We should also look at the statement for these records to look for patterns. Okay, so first convert the suspect list to a CTE so we can use it to filter the records from these 4 employees. So now this becomes our suspect list, right? Okay. So so let me see this and let me run only this and see something. Is it gonna work? No, it won't. Okay. Good. Okay. So first, convert the suspect list to a CTE so we can use it to filter the records from these 4 employees. Make sure you get the names of the 4 suspects and their mistake counts as a result using select employee from suspects list. So let's create a CTE. So create suspect list CTE. So okay. Will this work? Will this work? Will this work? Will this work? Okay, let me copy this and see something. So with suspect list, to select everything. Suspect list, right? I'll change it. I'll do the changes. Okay. Really. And hold on. So hey, right. Okay. So there's an error somewhere. So select employee name, number of mistakes as employee. This works. Then we'll select this from error count. Okay. Where from this error? Okay. Hmm. Um. Write the suspect list into a CTE. You can use it to filter the records from these four employees. Make sure you get the names of the four suspects. The honesty count as a result using select employee name from suspect list. So let me reference this. Just escape me a bit. Okay, so so it's happening oh, okay. Yeah. Still, we have an error down here. Let's work on that. Select everything from suspect list. Oh, okay. Sorry. So I think we get where the mistake is coming from. So because we are now creating this one as a suspect list, I'm just doing the changes because we're not going to use the error count. This is we are just creating the CTE for the let me experience something. Wait. So select employee account is also a wide number of mistakes. Goodbye employee name. Oh, okay. Okay. So I think I got it. So this won't be here actually. Um, let me go by employee name, right? So group by employee name. Good. So there we have it. Right. So we've now created our CTE. Okay. So we had to reference everything to reflect the suspect list here. So I had to change the error count to suspect list, both here and here. And then remove the other one that I think that was a error we were getting. So to find the employees who made more mistakes, yeah, we've already done this. You should get a column of names back. So let's just recap here. We're using correct records to find all the records where the auditor and employee scores don't match. We did that first. We then used the error count to aggregate the data and got the number of mistakes each employee made. Good. We did that. Finally, suspect let's retrieve the data of employees who make an above average number of mistakes. Yes, we just did that too. Now we can filter the incorrect record CTE to identify all the records associated with the four employees we identify. So firstly, let's add the statements column to the incorrect record CTE. Okay, then pull up all of the records where employee name is in the suspect list. So we will use select employee name from suspect list as a subquery in where. Okay. So we pull up employee name. Okay, let me see something. Okay. I get it. So let me give a comment. Add statements column to incorrect record CT. So add statements to incorrect record CT. So let me go for the incorrect. We already have a view table for that. So am I supposed to use the CTE? Well, the view is still a CTE, so I'll rather use the view than pull up. So let me do it this way and see. So select everything from um, incorrect records. This is what we have here. So employee name, location ID. Okay, so this one we are going to add statements. Okay, so selecting employee name. Then page. This is what I get. Let me how am I even joining statement? The statement is in the auditor report. Let me see. Auditor report. With the auditor report. Does the auditor report have a location ID? Let me find out and see. Okay. So location ID. Then I hope this one works. It's correct. So correct record. Nah, that will work. So I'm going to add statements. Statements is equal to and that will work. It actually worked. Okay. So villagers, blah blah, younger officials, good. So use the select employee. I didn't even use it. Maybe there's also another way that gave us everything. Oh no, I think there's an error somewhere. So where employee name includes, yeah. So I need to add that where employee name includes from the subquery. So where's the subquery for the suspects? Hey, where are you? Where are you? Where are you? Where are you? So this is the one we used to calculate. Okay. So there's the suspect list. Let me copy all this and see if it will work. Sorry. Suspect list. from this error or from this error. Let me just reference it. Yeah, that's the same thing I have here. So select employee name, number of mistakes. In this case, I selected everything from suspect list where number of mistakes is greater than select average number of mistakes. And then from suspect list, yes. So why this error? Oh, okay. So it includes select employee name. Okay, so not everything. So select instead of all of this should be employee name. Okay. Suspect list doesn't exist. So A. Correct records. Yes. Where okay. So let me remove this alias. It's not supposed to work. I don't know why the suspect list isn't working. So I already have the suspect list here as a CTE. Let me reference again. I'm finding it a bit challenging. So select employee name, location ID, statements from incorrect records. Okay. Hey, what's wrong? Oh, that's it. Okay. Hmm. Select employee name, location ID, statements from incorrect way. Yeah. Select employee location ID, incorrect records. Where employee name includes. Select employee name from suspect list. Oh, okay. So let me join this. I'm just trying to find the way around. So we have our statements from auditor report. And then I'll join it on location ID. Go to audit report also has a location ID. Okay, so we have employee name from incorrect records, location ID also from incorrect records, statements from audit reports. Let me run this and see. Still, suspect list doesn't exist. Oh, why are you giving me the stress? I have my suspect list here. I know why to prepare, so why? Okay, let me reference something here. So select incorrect records where employee name includes select. Yeah. Let me go in one by one and see something. So with error count as select employee name from incorrect and group by employee name here. This is it. Avoid. Then select employee name, number of mistakes from error count where mistakes is greater than good. This one also works. Okay. Then um oh okay. Okay. I get it. So this query is supposed to be part of. Oh, yes, let me copy it with the comment here. This is supposed to be part of. Let me actually cut it. Supposed to be part of this query here, right? So go up again. So number of mistakes. Okay. So guys, I'm actually delaying a bit here. Kindly pardon me. So goodbye. Selected by error count. Number of mistakes is greater than yes. Average number of mistakes from error count. Good. And then for corrupt leaders, we have select. Okay, so employee name, application ID, statement from incorrect records, and then where employee name includes is work. No, there's an error somewhere here. Hey, select distinct. Okay, employee name count, select average. Okay. Uh, something is not right. Something is not right. Error count as okay. So it starts from here. Select distinct. Employee name counts number of mistakes from incorrect records group by employee name. Then we select employee name, number of mistakes. Number of mistakes, error count, where number of mistakes is greater than the average. And then, okay. Let me see something here. Okay, so suspect list will also be a CTE here. Okay. Oh, wahala, wahala, wahala. So suspect list, but I've already created suspect list. Okay. So suspect list as this. Okay. And then okay. Then we select everything. Okay. Huh. Statement in field. Statement is filled. Statements. There, that's. Yes, incorrect records has statements. So why? Correct records also have statements. So why? Correct records. Oh, they didn't have the statements to the incorrect records. Eesh. How come? How come? How did I create a view? Oh, I've already created it. That means I have to drop it and create it again. Wait. Let me create it again. So create view, current records. Yes. I have to add what's the name? What's the name? Statement. Statement was part of the audit report. No. Yeah, some of this. Okay, wait. So yes, now we can run our query and then we'll get everything to work for us. Oh, so sorry. So this is how the table is now looking like. Okay. So from below Zibo, then it has the rest of the statement. So guys, this is the last part of it, and then that was actually what gave us a little bit of tough time. I was thinking of doing this in an hour, but I have exceeded an hour. So if you have a look, you will notice some alarming statements about these four officials. Look at these records. For example, you see how the word cash is used in a lot of these statements. Filter the records that refer to cash. So let me just type in cash here. And then you have about 71. Well, I think it's from all of them. So yeah. Oh, no, not 71. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 19. Okay. Check if there are any employees in the incorrect records table with statements mentioning cash that are not seen as a suspect list. This should be as simple as adding one word. So let's do it here. So select everything from incorrect table where so statements like where statements is equal to could be any where beginning with contains anything that has cash and also ending containing with every other thing else, right? Oh, hey. Okay. So running this, we get no um information from the table that states that aside these people, any other person also had cash relating to their name. Okay, so I get an empty result. So no one except the four suspects has these allegations of bribery. So we can sum up the evidence we have for Zuriel Matembo, Malaki Mavuso, Bello Azibo, and Lalita Kaburi. They all made more mistakes than their peers on average, and they all have incriminating statements made against them and only them. Keep in mind that this is not decisive proof, but it is concerning enough that we should flag it. President Naledi has brought her to stamp out corruption, so she would urge us to report this. I'm a bit shocked, to be honest. After all, our team set out to do, after all our team set out to do, it is hard for me to uncover this. I'll let President Naledi know what we found. Right. So, guys, this brings us to the end of our project for this week. Kindly pardon me that for the last part, I have to struggle with it a bit. It's usually sometimes challenging like that, but I hope this video helps out. So I'll be sharing it with you shortly. And if you have any other challenges, please feel free to reach out and I'll be always willing to assist. Thank you very much.